Okay, so this will be problem number 2 in section 5.1, and this question asks us to repeat what we just did, but this time form the rectangles both using the right rectangle approximation and then the middle or the midpoint rectangle approximation method. So the first thing we should do is draw in the rectangles. So I've already sketched the figure from before, and now they want me to, for this first rectangle, this time start from the right side to make the height. So now we're going to extend this direction. And then this rectangle will be here, here, and then this rectangle will be 0. Now, paying attention, I think it shouldn't be a surprise that this answer is going to be exactly the same, but let's see that the math actually does that. So I get area equals, again, the base is a half each time, so I'm just going to jump to that. And then I need the height of the first rectangle, which was the value at a half, and the height here was at, if you recall from the first problem, the height was at 3/4. That's the y value of this point. Here the value is 1, that was the y value. Here it's 3/4, and here it was 0. Alright, so then that means I simply am going to add 3/4 plus 1 plus 3/4 plus 0, which, looking back up at the first problem that we just did, you'll see that we didn't do the first 0, right? We didn't use this height, but we did use the 3/4, the half, and the 3/4, which we're using again, 3/4, 1, and 3/4, and this time we're using the height of the last rectangle, which happens to be 0, which was the same height of the first one. So that's why we're going to get exactly the same answer here. So we can go through all the math, but the answer is still going to come out to be the same, and we're going to get 1 square unit. Alright, so now let's work on the midpoint. And this is going to require us to do a little bit more work because while I know where my regions are, I don't know the heights of each of the rectangles because they want us to find the value at the midpoint. So the first thing I need to do is figure out where the midpoints are. And halfway between a half, of course, should be 1/4. Halfway here would be 3/4. This would be 5/4. And this one would be 7/4. So now I'm going to use those locations to determine the height of each of the red sections. So now, making the rectangle, I'll extend left and right from the midpoint in this first red region. Extend over, so I need to add a little there. Extend over, and then the last one. Alright, so that gives me these rectangles here. Okay, so let's write this one out. So I've got area equals, the base is still going to be a half, even though we're dealing with 1/4, but that's not the full base. We're still doing the full rectangle. We just found the 1/4 to be able to determine where the midpoint was. Okay, so we've still got a region with a rectangle of a half, and this time the height is going to be found for the first one, whatever the value is at a 1/4. So I'm going to say, for now, f of 1/4 plus the next one is going to be the value at 3/4 plus 5/4, and again f of, not just 5/4, and then plus f of 7/4. Okay, so now I got to figure out what that is, and I need my equation here. So let's see, I'll just rewrite it. The equation is y equals 2x minus x squared. Okay, so I got to plug in a 1/4, and I'm going to get 2 times a 1/4 minus minus 1/16. So I get 1/2 minus a 16th, or 8/16 minus 1/16. So that would be 7/16. Alright, now for 3/4, I'm just going to make a mess all over the place here. I'm going to get 2 times 3/4 minus 3/4 squared, which is going to give me now 3/2 minus 9/16. Common denominator is going to be 16, so that's going to be, what, 24/16 minus 9/16. 24 minus 10 is 14. We got minus 9, so that'd be 15. Alright. Now again, because of the symmetry, although my picture's a little bit off, the symmetry, we should know that these heights at 1/4 and 7/4 are the same, and at 3/4 and 5/4 are the same. So really, I can cut a corner here if I pay attention to things like that, and just add 15/16 and add 7/16. So I get 1/2, 44/16. Yeah. Which becomes half of 44 is 22/16, which can of course reduce to 11/8. And so that's the approximation I get using the midpoint. Okay, let's continue and finish this off. Number 3 says, using the same function as before, let's use our RAM program in our calculator to continue with this graph. Okay, so the first thing you have to do to use the RAM program is you have to go to y equals, and you have to type in the function into y1. So I've got 2x minus x squared. Alright, then quit out of that. And now we want to run the program. So I go to Program and select RAM. And then hit Enter. And it says A equals. So the A is the left side of the region that we're dealing with. So in our case, A is going to be 0. Hit Enter. B would be the right side of the interval, and that's going to be 2. Number of subintervals, we are going to do 10 this time. And hit Enter, and it's going to think for a minute. And it tells me my left is 1.32. My middle is 1.34. And my right is 1.32. And again, because of symmetry, it makes sense that the left and right are going to be the same. Won't always be the case. So now they want me to run it again. And when you're in a program, right now I'm still in program mode, so if I hit Enter again, it jumps right into the program again. So if you just hit Enter, you'll see an A equals shows up on your screen. So we're going to go from 0 to 2 with 4 intervals. Nope, that was wrong. Sorry, let's do that again. 0 to 2 with 50 intervals. It's going to take a minute to think. And I get 1.3328, 1.3336, that's really messy, sorry, and 1.3328. And, you know, to be thorough and finish the problem and to do good inductive reasoning, we've got to do more than a couple of examples. But you can quickly see, as we continue doing this, 0 to, this time, 100. And I have to wait for it to do its math. I think we already can see that the answer is probably going to be 1 1/3. That seems to be where we're heading. The more subintervals, the closer to the accurate answer, or the correct answer we're going to get. So now I got 1.3332, 1.3334, and this of course is the same answer as the other side. And enter 0 to 500. Now we've got some time to wait. So again, we can see what's happening. The 2.8 became 3.2, so that's getting closer to 3.3. The 3.6 went to 3.4, again getting closer to 3.3. So I think, I don't have the answer yet, but I already know it's going to be at least 3.33. And this one's going to be at least 1.333. And it's still thinking. And it's still thinking. This is good TV right here. Okay. All right, we're going to move on to number 4. I'll write this answer down when it pops up. Number 4 says, make a conjecture about what the area of the region R is. And I think the evidence points to the fact that the area of the region R is actually going to be 1 1/3 square units. I have my answer. It's 1.1, 2, 3. I have 4 3's. And back to 2.8. 1, 2, 3, 4, 5 3's. And a 6. And so again, we just got closer and closer to 1/3. So we can keep this up. It will never technically get to 1/3, but it'll be microscopically close. All right, we're going to end this video right here. And we'll pick it up with video 3 on number 5.